Hello and welcome to another LeetCode video. Today we're going to be doing the problem of the day for July 8th, put marbles into bags. It's a quite tricky problem. We finally don't have a sliding window, so that's already an accomplishment. And so in this problem you have k bags, and you're given 0 indexed integer array weights, where weights I is the weight of I marble, and you're also given the integer k. Divide the marbles into k bags according to the rules. No bag is empty. If the ith marble and the jth marble are in a bag, then all marbles with an index between I and j should also be in that bag. If a bag consists with all the marbles with an index from I to j inclusively, then the cost of the bag is weights I plus weights j. And then return the score. You want to return the difference between the maximum and the minimum scores here. Okay, so let's look at the first problem, or the first example. So we have 1351. All right. And our k equals 2, so we need to divide it into 2 bags. And so they're saying that the minimal score is this, and let's actually go over how we would calculate the minimal score. So the way you calculate the score for each bag is the jth index plus the ith index, and so if one element is repeated, then it's going to be that element twice. So it's going to be 1 plus 1 plus 3 plus 1. And so that's going to be 6. And in the second split, this is the maximal sum. So you have 1351. It's going to be 10. And then second example, let's see here. We have to have 2 splits, so the only distribution is this. And so when that's the case, the only distribution is possible, so the split is going to be 0. And in this first example, actually the split was 10 minus 6, so it's 4. So let's actually look at the first example one more time just to get a little bit more out of it. So when we do this first split, let's actually figure out how we're actually calculating our sum, right? So we have something like this. So the way we're calculating the sum is we're actually getting the first number and the last number. So let's just say first plus last plus the sum of every single place where you made a cut, essentially. So you made a cut in this 1351 here, and so you're going to make a cut, so it's 1 plus 3. So if you think about it, the first number is 1, the last number is 1, plus the sum of 1 and 3, and so you also get 6. And for the second cut, for the maximum, it's the same kind of thing. First, last, and the sum of every cut. So first is 1, last is 1, and the sum of the cut is this right here. So this is 8. And so if you think about it, you can kind of see that, for one thing, this gives you a big hint. So if the ith and jth marble are in a bag, then all marbles between index I and j should also be in that bag. That means that, like, if this is in the bag and this is in the bag, this is all in the bag, and so you know those are continuous arrays. That's one thing you need to know, and that's important. And the other thing is you need to realize how these cuts work. So wherever you make a cut, our sum is actually the sum of all the cuts. Let's actually go to a bigger problem to show this. So let's say we have numbers, and it doesn't really matter where we make a cut, it's all going to be the same thing. So let's just say we have numbers 1 through 8, or 1 through 9, or whatever. Okay, so 5, 7, 8, 9. Okay, let's say we have 3 bags just to show you. And let's just say we make our cuts here and here. So these are our 3 arrays. And so what's our sum going to be here? So remember, it's the first plus the last plus the sum of all the cuts. So the sum of this cut is 7 plus 13. And yeah, okay, and what's the first and the last here? It's actually 1 and 9, right? So 1 plus 9 plus 7 plus 13. So here we have 30, I believe. And so with this kind of cutting sequence, you would have a sum of 30. But essentially, if you think about it, you can make a cut anywhere, but your first and your last are always going to be included because no matter what array you have, there's going to be something in the start array, and it's always going to be I and j, and so I is always here, and j for this last array is always this. And then it's all about just where you make your cuts, right? And so where can we make our cuts? Well, we can make our cuts actually at every single location. So we can make a cut here, cut here, cut here, cut here, and so on. But how many cuts do we have total? So we have k minus 1 cuts. That's going to be important. But let's say we have, so once again, let's say we have cuts here, right? And so we have k minus 1 cuts, and we can make a cut at any single location. So how do we figure out the total using these cuts? So like I said, it's first plus last plus the sum of the cuts, where every single cut you will add both elements on both sides, right? So this will be like 3 plus 4, 6 plus 7, and so on. And so what we can actually do is we can calculate every single cut, like for all of these cuts, we can just calculate what the sum would be, and then we know that we have k minus 1 cuts. We can calculate the sum for all of these cuts, and then we can just sort the sums for all of the cuts, right? So we'll have an array of like the sums. So it'll be like, this will be 3, 5, 7, 9, 11, 13, 15, 17. And now that we have them sorted, it's pretty straightforward, right? We need to do the maximum minus the minimum. So the maximum minus the minimum is literally going to be this. So the maximum is going to be first plus last plus k minus 1 biggest cuts, right? We're always going to want the biggest cuts for the maximum. So that's going to be the maximum. Now minus first plus last minus, or sorry, plus this whole thing's together, plus k minus 1 smallest cuts. And so these cancel out. And so you have the k minus 1 biggest cuts minus the k minus 1 smallest cuts. Well, let's actually try to figure out how that would look, right, for this problem. So what are the biggest cuts and how many cuts do we have? So we have 2 cuts. So for the biggest cuts, it would be these 2, right? So we would want to have 15 plus 17. And so let's actually figure out what that would look like, right? So what are our arrays going to be to have these 2 cuts? So I think what's going to happen is we want our sums to be like this. So we want to cut here. I think it's actually like this. Let's just double check what the total here would be. Okay, so the total here is going to be 1 plus a cut here. So that's going to be 15, right, plus 17, right? And then plus 9. Okay, so that's going to be what our biggest cut array is going to look like. And now what's our smallest cut array going to look like? Well, it's going to be kind of similar, except we want to use the 2 smallest cuts. So if we want the 2 smallest cuts, we just make an array on both sides of the cut. So here, and then we make an array here. And it would be like this. So this would be our 3 arrays, and it would be the same kind of thing, right? Where this would be 1, 1. This would be 1, 2, 2, 3, and then finally the 9. And so that's how you can make these cuts. Now this is not always going to be sorted, but essentially you can sort your cuts, and then once you sort your cuts, you just greedily take the biggest cuts you can and the smallest cuts you can. You know that you're going to have k minus 1 cuts. That's the way you're going to make your array, and that's going to be how we're going to get the answer. So I think it's definitely tricky to figure out that you want these cuts. You want to focus on the cuts, and it's also tricky to figure out, like, I think for most hard problems, people usually go for GP, which I definitely did at first. And it's definitely tricky to figure out this greedy solution, because greedy solutions a lot of times don't work, so it's kind of like a guess and check. You kind of have to try it and see what happens, and like, did it pass or did it not? But yeah, essentially, once you figure out that you're making these cuts, and how to get a total is just literally the 2 numbers on the side of a cut. So you have k minus 1 cuts, and then for each cut, the 2 numbers on the side of the cut are the total. And it's first, this is like how you calculate the min and the max. You subtract them, the first and last cancel out. And so now that you know that you get your array of cuts, you sort it, and then you just take however many cuts you need from the minimum, however many cuts you need from the maximum, and subtract them. So now I think we have enough to code it up. Okay, so we're going to have our pairs, or our cuts, let's just call it our cuts, equals this. And so for I in range, so we're going to try to make a cut at every single location. So it's going to be weights minus 1. So we're going to compare every single number to the number after it, right? So like in this example, we're going to compare these two, and these two, because you need to make a cut in the middle of 2 numbers. So we're not going to use this last element because there's nothing after that. Okay, so we're going to pairs.append, or actually it says cuts. cuts dot append, and then we're going to need weights. So what are we doing? We're doing weights I plus weights I plus 1, right? Because if we're making a cut here, let's say at this 1, 3, then at that cut we're going to add the 1 and the 3, and just to double show you one more time what that's going to look like. So if we have this 1, 3, 5, 1, let's say we have 1, 3, 5, 1, if we make a cut here, we're essentially saying let's take this array and this array, and then this will be the j here, and this will be the I here, right? So it's you would add those together. Okay. So this is gonna give us every single cut. Now what do we do next? Pretty straightforward. We have to sort our pairs. So cuts once again. Cuts.sort. Now, what do we need to do? So I'm actually gonna write up a list, a slice. You could, I think probably the better practice would be, we could do that as well. So yeah, I think the better practice would be just for loop k minus 1 times, but I'm actually just gonna write out a slice, and for the slice, what we're gonna need to do is we are gonna need to check if so think about what would happen in this case. If you only have one cut, then you would need the whole array, and so the min and the max would be exactly the same. So we can just return 0 because the difference is gonna be there. And also this would break my, so I ran this before, if I don't check this, then I can't do like a sum, because it would break my slice, but I'll show you that right now. So we're gonna have a return, we're gonna have a sum, and so this is gonna be the maximum. And so think about where's our maximum gonna be, and how many cuts are we gonna have, right? So we actually wanna have k minus 1 cuts, and so for our list comprehension, like what would happen if we write something like this? This would give you the last 3 elements. So that's what we want. We want minus k, but we want to add 1 here because we want k minus 1 cuts. So if this is like, if k is 3, we'd want minus 3 plus 1, which would give us a minus 2, so we'd get the last 2 elements. So that's how you get the max, is negative k plus 1, and we just slice. Now we subtract the sum, and so how do we get, oh, by the way, this should be cuts. It should be cuts. And then how did we get the first X amount of elements? So if you think about it, right, how many elements would we want? Like in this case, if k equals 2, we'd only actually want 1 element, so we'd want the element at index 0. So we're going to start at index 0, and where do we want to stop? We actually want to stop it at k minus 1. And so because this element is not included, now if k is 2, this will evaluate to 1, and then we're essentially getting cuts of 0 to 1, which would just be cut 0, and that's the number you'd want there. So this is going to give you the max, this is going to give you the min. Remember, the first and the last cancel out, and that's actually all the code. So let's see what happens. Okay. I think it's definitely, once you get that you need to think about in terms of these cuts, and you can just be greedy because you can make a cut literally anywhere you want. You can always have an array of 1 element, so you can make a cut right next to each other. You can always have an array of 1 element, and you need to figure out how many groups you have. I think this problem is not too hard. I think the hard part about this problem is kind of getting to the solution, but once you realize, like, hey, this is the solution, the code is really easy, everything else is really easy. So probably not a huge fan of this one. I think I'm a bigger fan of problems where even if you know the solution, it's still hard to code, but, you know, at least it's not a sliding window. And so let's do the complexity analysis. So this should be pretty straightforward, right? This is a n complexity. Sort is n log n, and this sum is n at worst. So space, what do? We made a cuts array, and we made a cuts array of every single cut, and so that can be, you know, I think k can be anywhere from, yeah, it can be close to weights length. So that's obviously n. And yeah, I think that's everything. Yeah, so that's going to be it for this problem. Hopefully you liked it. And if you did, please like the video and subscribe to the channel. And I will see you in the next one. Thanks for watching.